A student took 2 tests and the probability of them passing at least one of the tests is 0.9. Define 2 events, C1 that they passed the first test and C2 that they passed the second test. Suppose the probability that they pass only the second test is 0.5. Then what's the probability of the event C1? So let's first start by writing down what information we know. So we know that the probability that they pass at least one test. So that they pass at least one. So when we see the word at least, that usually means it's a union. And in this case, it's the union between C1 and C2. And if we think about that, the union between C1 and C2 refers to the event where either C1 happens or C2 happens or both of them happen. And that's what at least means. So based on the question, this is 0.9. Now, usually it's helpful to write down all the information you can get from that, and then we'll see what's helpful later on. So what I mean by that is we know what its complement is. We know this event and we know its complement. So the probability of C1 union C2 complement is 1 minus 0.9, so 0.1. Now, one other thing that you might notice here is this expression C1 union C2 complement can be written in a different way by De Morgan's law. So this, by De Morgan's law, covered in a previous video, is equal to the probability of C1 complement intersect C2 complement. So these two are equivalent by De Morgan's law. And we're writing that down because we're going to see what's helpful later on. Now, the other piece of information we know is the probability that they pass only the second test is 0.5. So what's the probability that they pass only the second test in set notation? So it's the probability that, well, if you're only passing the second test, that means you didn't pass the first test. So it's the complement of the first one. And, so intersect, you're past the second test. So this means you only pass the second one. Only pass the second test. And this, based on the question, is 0.5. And what we're trying to solve for is we want to know what is the probability of C1. What's the probability that they pass the first test? So this is where experience and a lot of practice usually helps to recognize what kind of equations you might need or how to put things together. So when I look at this, I notice that they're giving me this piece of information here, and there's a complement in it. So that probably means that I'm working in terms of complements to start with. So let's try looking at it this way. Let's first find the probability of not C1 happening. Now, what's usually helpful is to look at a Venn diagram to figure out what things equal when you're not sure. So let's look at a Venn diagram. Here we have C1, here we have C2. And now the question is, what is the probability of not C1? So what is not C1? Not C1 is all of this. So it's this whole area. Now, how can we put together different pieces to get that area? So let's look at the information that we have. We know that the probability of C1 complement so that's this part, C1 complement and C2 is 0.5. Well, what's that? How can we show that on a Venn diagram? So the intersection between C2 and not C1. Well, C2 and not C1, that's simply this portion. That's this portion here. And we can see that because, well, this is C2. Everything that's not C1 is what we had originally in that blue. So then where do they intersect? Well, it's this green part here. So we have one piece of it. Now we want to represent what's this remaining portion? What's this blue area? What is that in set notation? Fortunately for us, if we look back at the information we have, we see that that is the same thing as this. Because everything that's not C1, so everything outside here, intersecting with everything outside here. So that's the blue area. And we see that they don't overlap, which means that we can just directly add these two pieces together. So what all this means is the probability of C1 complement is equal to the probability of that green portion, C1 complement intersect C2, plus the probability of C1 complement intersect C2 complement. Now, if you're still a bit unsure about where I got this from, we can also look at this from another perspective. When we're adding things together, in this case, it's the union of the two areas. And there's no, as I said, there's no overlap, so there's nothing that you need to subtract. So we can look at this in a slightly different way. We can prove that this relationship works because we have the probability of C1 complement intersect C2, or really we don't need to write the probability here, we're just trying to show that these sets are equal, unioned with C1 complement intersect C2 complement. What you might notice here is that we can factor out a C1 complement and that's being intersected with what's left is the C2 unioned with C2 complement. Well, C2 union with C2 complement, that's just the entire set. That's just the entire sample space. So then this just boils down to C1 complement. And that's, again, shows where this equation came from. So that's two different ways of looking at this. So now we can put in the numbers, we can solve for this. The probability of C1 complement. So the first part here is 0.5. And we're adding to that, the other part is 0.1. So this is 0.6. But we're not done yet because the question was really asking for the probability of C1. But that's just 1 minus the probability of the complement. So 1 minus 0.6, which equals 0.4. Now, there's another part to this question. So now let's ignore part A. And now let's suppose the probability of them passing the second test is 0.6. Then what is the probability of the intersection between C1 and C2 complement? So let's again write down what information we know, which is already what we stated to begin with. We can't use the information in part A, but the question did say that the probability of them passing at least one test is 0.9. So, as we said before, we know the probability of C1 union C2 is 0.9. And let's look at a Venn diagram to break this down, because we want to know what is the probability of C1 intersect C2 complement. So let's draw our Venn diagram again. So we have C1 and we have C2. So C1 intersect with C2 complement. So let's think about this. C1 is obviously this circle. And then the question is, where does that intersect with everything that's not C2? So everything outside of here. So it's everything in here and what's common between everything outside of here. So hopefully you can see that that's just this. Now, like we did before, let's try to think about how we can put different sets together to get that area. So what you might notice is that area is if we start with the probability of C1 and we subtract that common portion, which is where C1 intersects C2. Now, unfortunately, we don't have any of that information. We don't know what the probability of C1 is, and we don't know what the probability of C1 intersect with C2 is. But there's another equation we can use in this situation. So as we might remember, the probability of C1 union C2 is equal to the probability of C1 plus the probability of C2 minus the probability of their intersection. We proved this relationship before. So now using this, we're trying to get this portion represented in a different way. Well, that's just this and this. So what's left, so if we continue with this, that's really equal to the probability of C1 union C2 minus the probability of C2. So hopefully you can see what I did there. I just rearranged this equation to replace this expression. And now we know this information. We know the union of C1 and C2 is 0.9. And we know that the probability of C2, which I didn't write down, but based on this question, it says the probability of them passing the second test. So that's the probability of C2 is 0.6. And we get 0.3.